second derivative test. What Alec came up with before.
What
Okay?
I invented without even knowing.
Exactly. We're going to call you Alec Leibniz for short. Yeah.
Short.
Okay, so this test isn't necessary, but it can save time in that it saves you the whole first derivative number line time, right? As long as the test doesn't fail. Because you know that you have to, unless you use your second derivative, you have to get your concavity anyway, right? So if you just take your first derivative, set it equal to 0, and then go through your second derivative stuff, you will find that you kind of already have your answers. How do I want to say this? I'm going to come back to this in a second if you're writing it down. But back on this graph here, if we would have set this thing equal to 0 and got -6 and 0, but not done the number line, okay? Then we go over to the second derivative test, or the second derivative for concavity, and we do this stuff. We would go, all right, now I want to know what is f double prime of 0. Let me do this in a different color. What is f, yeah, see how weird this looks now?
It's like skinny.
F double prime of 0, and what is f double prime of -6? And that could tell you if that was a min or a max, okay? F double prime of -6, you've already done it. That's why I say it's a time saver, because you already tested something back here, didn't you? So you know that at -6, it's going to be positive. Now, at 0, though, it happens to equal 0. This is where the second derivative test fails. But here, the second derivative test works, and it tells you that because this second derivative at a critical number, where the derivative is 0, because it is positive, your graph was concave up, and because it's concave up, you have a relative min. So it saved you having to do that. Although it kind of didn't save you because the test failed here, and you would kind of want to know what was going on anyway. Maybe. Unless you realized it was a point of inflection. You know? So it really can be a time saver, but the only thing is that sometimes the test fails. So, again, you set the first derivative equal to 0, plug that number into the second derivative, and if it's positive, it has a local min. If it's negative, it has a local max. Okay, x over the quantity x minus 1 squared. Okay. How about we get asymptotes first?
Yeah, let's have so
Vertical asymptotes, horizontal asymptotes.
power on the
Okay.
bottom.
So, again, go back to horizontal asymptote shortcuts. If the degree of the top is lower, it's at y equals 0. All right, vertical asymptotes? Yeah, good. And it's not only because it makes the denominator 0, but because it does not make the numerator 0. Okay? Remember, if I put a 1 back into this function just to make sure Colin was right, and if I got 0 over 0, I'd go, never mind. Because 0 over 0 is something else. It's like a jump or a hole or something. Okay? All right, so your asymptotes are there now. Guys want to erase me?
Sure.
What rules? Well, what rule am I using, at least to start with? Quotient rule. And then when I get to the derivative of the second, I'm going to be using the chain rule / general power rule. It's up to you once you get the first derivative. If you want to factor out a negative sign and have that numerator be an x plus 1 and have a negative sign hanging out, it's up to you. stuff's canceling.
First derivative is good.
If you guys are doing homework and you're doing derivatives that take this long, wouldn't hurt to like Wolfram Alpha check your derivatives or something. Okay, so now I have my derivatives. Now I'm going to use them. This is where I probably could have used the longer page, right? So we're going to do extrema by using the first derivative. I'm going to start just, well, so the first one, I'm going to get x equals -1. When I set the top equal to it, equal to 0, I'm going to get -1. When I set the bottom equal to 0, I'm going to get 1. Okay, so if I put in a -2, now I do have to worry about the top and the bottom here, okay, because the bottom is cubed. So a -2 minus 1 is going to give me a negative. A -2 minus 1 is going to give me a negative. Cubed is negative. So that fraction is going to be positive. If I put in a 0, I'm going to get a negative. And then if I put in a 0, I'm going to get a negative. Cubed is negative. Yeah. Then if I put in a 2, -2 minus 1, am I always getting a negative? No, I missed something. Somebody want to fix it for me and get a ticket?
The first one should be a positive.
Yeah, positive over negative. Good. I forgot to negative my 2. Okay, a -2 is 2. So this should have been positive, which meant that should have been negative. I did it myself. Hey, since this was a first derivative, what is this telling us? What about the function?
It's going to be an x squared deal. Well, I lied.
Yeah, like a negative x cubed type
Yeah, that's
thing.
completely valid.
Or maybe not, because there's asymptotes. I kind of want, you know what, I am going to finish this. Let's try to ignore the people coming in for just a little bit. Mr. Withrow's staying up in the lab, and Mr. Haladio is going to be late. So we'll just finish. All right, concavity. Second derivative. So there's a paper towel dispenser over there, huh? Did you hear all that noise? It was a different noise. Okay, so 2x equals -4, -2. And we have 1 from the denominator. Okay. So -3 is going to give me what? Negative on top. Look at the bottom. Do I have to worry about the bottom ever?
No.
No, to the
It's gonna be
fourth.
positive.
Right. So if I put in a -3, and if I put in a 0, if I put in a 2. Okay. So what does that tell me about the graph? Yeah. Ah!
Oh, who?
Hey,
Guys,
Mr. Cosby.
Oh my gosh.
What happened? He's leaving.
Okay, guys, I'm not scrolling up. Where were my vertical asymptotes? I don't remember. Or did I have 1? Huh? At 1?
At 1.
One, and then the y.
And the horizontal?
X-axis.
Okay.
What?
Black and yellow, black and yellow. Ah. Okay. All right. So
This is all
here.
when you get back to the
I can't step in front of the camera now. Okay. -1.
Sorry, I just had to.
That's okay. Oh. Okay. Now you would normally say that this is what, a min, and that this is a max. What happens when you plug in a 1 to the function? Again, I'm not scrolling up, but you look at what happens when you plug in a 1 to the function.
Get a 0 and then go 1.
Right. So this max, it shows up as increasing, decreasing, but it's also an asymptote, so it's not a max. It's just where.
It approaches it. It approaches it.
Yeah, right. It's probably gonna go. Yeah,
It
it's.
goes up, and then on the other side it will go down.
Yeah. Okay, but this I gotta find my minimum value. Okay, thank you.
1/4.
Okay. I'm not looking so. Okay. So negative 1, negative 1/4. That's my min. Points of inflection. Again, I know I don't have to. For points of inflection, again, this one's not going to end up being one, right? Because one something is undefined. But negative 2.
Negative 2 nines.
Yes.
I don't know me, but I know you matter.
Okay, so negative 2, negative 2 ninths. I think I'm just going to do this. Negative 2, negative 2 ninths. Okay. Okay, so that's 0.2 repeating, that's 0.25, so they're close. All right, so now let's go based on concavity, okay? From negative 2 back, I want to be concave down, and I want to hug this horizontal asymptote.
But don't touch it.
Yes? Don't touch this.
Oh my.
It's super free.
Ah, but it's also hammer time.
Super free.
Both.
Original.
And MC hammer.
No, coffee.
Okay, that's your concave down. Now we need concave up, right? We need concave up, and we need to hit our minimum along the way, so it needs to decrease to here, and then it needs to increase. Do you see it? It needs to be concave up and hit the min. Concave up and hit the min. Try not to make that look as like cornery as I did. You know what I mean? Because that's bad. It almost looks like the derivative doesn't
Does
exist.
it mean it's going to come back down on the asymptote?
Okay, here is the question. Okay, this will be easy for some of you, not as easy. Okay, two things are going to happen. It's going to decrease, right? It's also going to be concave up. Everybody, I want to see all of your eyes. 1, 2, 3, 4, 5, 6, 7, 8. You have two choices: this or this. Those are your choices. Yeah, this is the one that decreases and is concave up.
It's increasing or decreasing.
Yeah, from left to right, it's decreasing and it's concave up. But you know you have to follow those asymptotes. All right. Anybody want to say bye to Bobby? Bye, Bobby. Hi. I don't know.
Understand.
Oh, okay.